So this is chapter 6, part 3. We're talking about temperatures here and where these microbes, the ranges of temperatures these microbes prefer and thrive in. So when we talk about cardinal temperatures, it's minimum temperature, maximum temperature, and then the optimal temperature. So it kind of is self-explanatory. So minimum temperature is the lowest temperature that permits the microbe to grow and survive. The maximum temperature is the highest temperature at which will allow growth and metabolism to proceed. And optimum temperature is um, the best temperature, the favorite temperature this microbe prefers, promotes the fastest rate of growth and metabolism. So we're going to go over a few different types or categories rather of these microbes. So the first category would be Psychrophiles. They have an optimum temperature of below 15 degrees Celsius. All these temperatures are in Celsius. They are able to grow at 0 degrees Celsius, and they prefer, they can't survive over 20. So storage at refrigerator temperatures will cause them to grow. Natural habitats of psychrophilic bacteria, fungi, and algae are places like lakes and rivers, snowfields, polar ice, and deep in the ocean. These guys are rarely pathogenic when we come across them. Okay, so that was Psychrophiles. This is Psychrotrophs. Okay, these guys grow slow in the cold, have an optimum temperature between 15 and 30. Examples, Staphylococcus aureus and Listeria monocytogenes are able to grow at refrigerator temperatures and cause foodborne illness. So if putting it in the fridge is going to only make it worse if you haven't gotten rid of these guys before you store it. So, foodborne illnesses, Listeria and Staphylococcus aureus are common in that respect. Mesophiles, majority of medically significant microorganisms are mesophiles. They grow at an intermediate temperature between 20 and 40, inhabit animals and plants as well as soil and water. Human pathogens have an optimum temperature of 30 to 40 C, and our body temperature is 37 degrees C, so you can imagine that these guys really like that and are able to reproduce and live within the body and cause illness. Thermoduric microbes can survive short exposures, a short duration. Okay, thermo meaning you think of temperature or thermal heat, right? And then duric is duration. I think of as duration. So these guys can survive short durations of exposure to high temperatures, but are normally mesophiles. So they like these temperatures, but they can survive for a short time at higher temperatures. Common contaminants of heated or pasteurized foods. Examples are endospore formers, specifically Bacillus and Clostridium. So as I move through these, what do you have to know, right? Whether it's super high temperatures, super low temperatures, body temperature, and then a few examples. I might ask about Bacillus and Clostridium being thermoduric, right? These guys are common contaminants of heated or pasteurized foods. That is a very typical question that could come up on the homework, the quiz, or the exam. Thermophiles, they like hot temperatures. They like 45 degree plus. And again, we're talking Celsius here. They live in the soil and water that are specifically associated with volcanic activity. Compost piles, if you've ever gotten near a compost pile, there's a lot of heat that's coming off of them, and sometimes you can actually see, if it's cold outside, you can see kind of the steam coming up from a compost pile. So those guys it's a lot of heat going on in there. And in Thermophiles also prefer direct sun. Vary in heat requirements with a range of 45 to 80. Most eukaryotic forms cannot survive above 60. So the thermophiles that are eukaryotic will not, go up to that 80. Well, it won't survive in that 80 range. And extreme thermophiles can grow all the way up to 121 degrees Celsius. This is just kind of like a temperature range chart here. I'm not really worried about that too much. So moving on, other things that microbes prefer or need, okay? So it has to do with gases. The atmospheric gases will have an influence on microbial growth, and the ones in particular that do are oxygen, O2, and CO2, carbon dioxide. Oxygen has the greatest impact on microbial growth and is an important respiratory gas and a powerful oxidizing agent. It is important to note, though, and I'll talk about this a little bit later, that oxygen, when microbes get a hold of oxygen, there's some toxic byproducts that are made. So, and we'll talk about that later, but there are some microbes that are able to take care of those toxic byproducts and deal with them. And then there's, others that are not. So, all right, so oxygen has the greatest impact on microbial growth. It's an important respiratory gas and a powerful oxidizing agent. Microbes fall into one of three categories: those that use oxygen and detoxify it. So they can use the oxygen, and then they can take care of the byproducts. Those that can neither use oxygen nor detoxify it, and those that do not use oxygen but can detoxify it, if that makes any sense. But we'll get to this as we move forward here. So how microbes process oxygen. As oxygen enters cellular reactions, it is transformed into several toxic products. Singlet oxygen, reactive molecule that can damage and destroy a cell by the oxidation of membrane lipids. Superoxide ion, which is a highly reactive byproduct. Hydrogen peroxide, toxic to cells and used as a disinfectant. And then hydroxyl radical, also highly reactive. So these are examples of the toxic byproducts that I was mentioning earlier, right? These are, I think this might be a test question as far as identifying which of them are toxic byproducts. So how microbes protect themselves against those byproducts. Most cells have developed enzymes that scavenge and neutralize reactive oxygen products. So in other words, these cells can have adapted to be able to, find a way to utilize or neutralize the byproducts. I'm not going to ask you this right here. This hurts my head. I'm not a chemistry major, and I have no desire to be, and I'm not going to ask my students to be. So you don't have to worry about this, but you should just be more concerned with what was on the last slide as far as these toxic byproducts. How they are gotten rid of. One of the labs that comes up later, we'll talk about how hydrogen peroxide is converted to water and oxygen by catalase, but that's a whole nother topic, and we'll get to that later on in the semester. All right, so I'm going to stop here and pick up on this next part of chapter 6.